Hello, we're going to do notes for worksheet number 3 in the gas laws. If you've been following me, which you probably haven't, this is probably going to be my 11th time trying notes for worksheet number 3. I hope this is the last time I try recording this. So molar volume of a gas, it means the volume of 1 mole of a gas. So 1 mole of any gas at STP is 22.4 liters. So that means 1 mole is 22.4 liters, or 22.4 liters is 1 mole. You can use it as a conversion factor, just like 12 inches is 1 foot. Gas stoichiometry. So we're going to do number 1A from worksheet 3. And it says how many liters of oxygen gas, so let's make this into a problem. How many liters of oxygen gas will be needed to react with 25 grams of propane? It's all balanced, and we're going to do stoich from there to there. And this is at STP, so this is going to make it easier. So we'll start out with 25 grams of C3H8. We'll change it into moles. 1 mole of C3H8 has a certain mass. That's an 8, believe it or not. It has so many grams. If you add up 3 C's and 8 H's, you'll get 44.09 grams. Now we do the mole ratio. And so on the bottom, we put the one we want to get rid of, 1 mole of C3H8. For 1 mole of that, there are 5 moles of oxygen. That is the mole ratio. Those are the coefficients in front of the numbers. Ta-da! And there's a 1 there that's understood but not written. Now, here comes the easiest part. 1 mole of oxygen gas is 22.4 liters. That's where that STP came in, and what we wanted to find was volume in liters. So we go 25 divided by 44 times 5 times 22.4 liters, and that gives us a total of 63.5 liters of oxygen gas. Beautiful thing. Now we're going to move on to the next slide. We're a little slow, but we're moving. Avogadro and the gas laws. So now we're talking about moles, and moles are represented by the letter N, and we have P1, V1, N2, T2 equals P2, V2, N1, T1. Let's try the next problem. Oh, we're not going to do the next problem. We're going to do the ideal gas law. So PV equals nRT. That's the ideal gas law. I call it PIV NERT. P is pressure, V is volume, N is moles, R is the universal gas constant. It'll be given to you on a test. T is temperature. R is 0.0821 liters times atmospheres divided by moles divided by kelvins. The moles and kelvins are multiplied, so are the liters and atmospheres. So we're going to do problem number 3 from worksheet 6. It says a 1 mole sample of water evaporates in a flexible container at 127 degrees Celsius and a pressure of 0.908 atmospheres. After the evaporation, what will be the volume in liters of the container? So I'm going to write down what I know. So what do I know from this problem? What information is given? I know I have N equals 1.00 moles. And that's a beautiful thing. And the next thing is temperature is equal to 127 degrees Celsius. We can't leave it in degrees Celsius. We have to add 273. So that equals, which one am I on? Or I'm on number 6, sorry, not number 3. I'm on worksheet number 3, number 6. So the temperature is 400 K. What's the next thing I know? Pressure. Pressure is 0.908 atms. And we're trying to find volume. We don't know volume, and we're trying to find it in liters. So I look at what I've been given, NTP, try to find V, and I know R. R is a constant. So I'm going to use PIV-NERT as my equation. PV equals nRT. I'm going to isolate V. That's what I'm trying to find. So V by itself is nRT divided by P. I'm going to plug in my numbers. So V equals 1 mole times R. I love to write out all the units for R because it helps you see the units and to cross cancel them. So it's liters, atmospheres over moles, kelvins. Now you've moved into the big time. You're doing fractions within fractions. That means you must be very smart. And then we have 400k as the t all over p, which is 0.908 ATMs. And now I want to cross-cancel my units. Let's see if we change colors, if this works. So let's see, our moles, we change colors, cancel our moles. Our K's cancel the K's, the ATMs cancel the ATMs, and we're left with lovely liters, letter L. So V equals 36.2 liters. Shazam. That's a beauty. And those would be the notes for worksheet number 8. If you enjoyed doing work, it's quite pleasurable for you.